there's a lot of amazing things you can do with Spring today. And I wanted to just sit down and kind of explore some of that. Now, we don't have a lot of time together, but we'll just take an abbreviated look at the wonderful and wild world of Springdom in 2025. Now, obviously, some of this stuff will be subject to change. As time progresses, we might add more and make it even more impressive. And obviously, we can't hope to cover everything, but let's just take a look and walk through some of the common scenarios that I think will be very useful for somebody working in Spring or trying to get started with Spring. So with that in mind, here's the code if you want to follow along at home and play the home game. And of course, what we're going to do is we're going to build an application to support adopting dogs. Now, this is a silly but wonderful endeavor, and it was born out of my dog. I have a dog whose name is Peanut, who's not a good boy, not a good dog, but he's ours and we love him, and so we keep him. And I was thinking, like, there's some pretty weird dogs out there that I'm sure would be fun to have around the house. So wouldn't it be nice if there's like a dog adoption service or something like that? So that's the domain. We're not going to linger too much on that domain, but I just want you to keep that in the back of your mind as you see me talking about dogs, okay? And we're going to build a new application, and we've got a few different things we need to work at, but first let's just talk about basics with Spring. Okay, we're going to just talk about the absolute basics. If you already know a little bit about Spring, then this bit is it's probably not for you. Feel free to skip ahead to the next section, but we're just going to take a look at the basics with Spring. I'm going to generate a new project here on start.spring.io, and this is going to give me a build file, and I'm going to use Maven, or you can choose Gradle or whatever. It's going to give me the current version of Spring Boot. As I record this is a sort of March of 2025. Spring Boot 3.4 is the current thing. In May, we'll have 3.5, and then of course in November we'll have 4.0. So again, things are subject to get even more impressive the further on down the line you go. We're going to use Java 23, but again, about a week from now, actually, Java 24 will be out. So I'll be using that a week from now. Okay, so what do we want to call this first service? Well, we're gonna generate and create something called a Spring Cloud Config Server. We'll talk about what that is in a second, but I just need a project in which I can work and demonstrate some basics of Spring before we can get into the actual nitty gritty. So to that end, I'm going to bring in the config server stuff. If you don't know what that is, it's fine, just ignore it for now. I'm going to bring in the Spring Framework web support. Let's go to the downloads directory here and then open that up in my IDE. Okay, now look, this is a Spring Java program. It's got a public static void main. You can see it's right here, public static void main. But this is all for Spring Boot, right? Look at what you would have if you had just regular Java, right? This is just a regular Java class right here, public static void main, and so on. And what Spring does is it gives you a way via 4 key concepts: portable service abstractions, AOP, aspect-oriented programming, dependency injection, and of course, in Spring Boot, we have something called auto configuration. So these 4 concepts are everywhere in Spring. You'll see them all over the place. What do they mean? Well, this just means that where there is boilerplate code that could be abstracted away, we do so. We provide types that ensure you have a familiar, consistent idiom by which to sort of work with resources. A common example: suppose you want to work with data, right, using a SQL database. Well, you might use JDBC. JDBC requires you to create a statement, create a connection, and then remember to cycle through the statement, to get the result set, and then cycle through the result set. It requires you to close everything down, and it can be very, very painful and tedious to do all that, all so that you can run one little string and then map the results back to objects of your domain type. So you might use something like the JDBC client to make much shorter work of that, okay? Or you might have seen something like the JDBC template, which you could still use, but I prefer the client these days. The JDBC template is, however, much older, closer to 20 years. So you can use either one, but the idea is that makes most operations with your SQL data store a one-liner, as opposed to this very verbose, exception-riddled, resource handling laden thing, right? So portable service abstractions are just types that automate away the interactions with otherwise cumbersome resources. Aspect-oriented programming is the idea that you can, through dependency injection, that's this right here, you can decorate objects with new functionality. So in order to understand that, really, as I just alluded, you need to understand dependency injection. And this is just a fancy name for writing objects in such a way that you provide other objects. I mean, it's not special, right? So imagine you create a service that's going to manage your customer data, okay? Well, maybe if I did that, I say class customer service, and my customer service, in order for it to do its work, it needs a pointer to my Postgres database, right? My database like that. And I could definitely instantiate the database here in the constructor. But, you know, I could just new this, that, and the rest, but I don't want to do that. Instead, I want to have it injected. And the reason I do that, and when I say injected, I mean provided for me via the constructor, or less often, but still plausibly via a setter, is because, so you might do a public void, let's see, I can just do void set data source, right? Like you could do that as well. And then if this wasn't final, you could use that. But my point is you want this to be provided to you from the constructor and passed in. That way, if you write a unit test, you can mock this out. You can make this an empty object that doesn't actually connect to your SQL database, right? Or if you move from one environment to another, you, in your development environment, in your local machine, you can have a development database, and then in production, you can have a real database with, you know, clustering and connection pools and a higher thread count and all that. Either way, you get that optionality by working in terms of the lowest common denominator interface. In this case, javax.sql.datasource. If you had typed this down to Postgres or something like that, or, you know, a particular kind of data source, I can't even think of one because it's so often that you do. So it's not very often that you do that. If I did Hikari data source, I don't think I have this on the class path because it's optional, but you could do something like that, right? If you did that, then you'd be limited to just that data source. You'd have to configure one of those each time, and that limits your optionality. So again, architecturally, you want to do as much as you can to enable optionality. Dependency injection is just a style of code where you write your code in terms of these sort of optionality restoring things, and then you configure these objects, you wire together these objects through dependency injection. That is to say, you have a single place in, well, let's try this. You have, you know, my config, right? You can imagine having a function that'll build up a data source for you, like so, right? And I'm not going to return it, but you can imagine. And then maybe we have another function that returns a customer service, right? And so this is not Spring, this is just regular objects. And then if I wanted to get the data source, I could say, you know, this dot data source, and then inject that, right? So now I have one object being injected into the other, right? And so finally, if I have a program that needs to run, like my, if I want to actually use this customer service, or if I have a main app or something, right? I can, over here, I can go my config equals new my config, and I can get the objects. I can say, give me a customer service object, and then I can use it to do something interesting, right? And I can know that it's been fully configured here. And if I wanted to, I could actually maybe make it a little bit more dynamic so that this took a data source, right? And so now, you know, the user would have to provide the data source, but they could do that, right? It would just be like this, right? They'd get the data source from the config and then provide that there and then use it. The reason you want that optionality, though, in this case, I don't want that data source being declared there. The reason you want that optionality is, again, because this might be a test data source in your test code. It might be a real one in production and a sort of lightweight one in your development environment, okay? So dependency injection is very good, and it relies upon polymorphism. Polymorphism is the concept that if you put something in your class that is of a particular interface, then anything that implements that interface that has the same shape as that can be substituted. So I can use a Postgres data source, a MySQL data source, a Hikari connection pooling data source. I can use any data source I want because they all implement data source, right? And that has some interesting implications because you also have the ability to introduce subclasses. So let's say I had let's say I have class my, let's just say this is the Oracle data source. It's definitely not, right? It's just a data source, but let's just imagine that I had implemented somehow my own data source, right? Which you should never do. It's a terrible idea. But let's say I did, okay? Let's say that this is now the official Oracle data source. But it doesn't, and it's packed, and let's say that this is packaged up in a jar, and it doesn't do one little thing that I want it to do, right? What if I want to have logging that precedes and succeeds every single time I call one of the methods on this official Oracle data source class? Well, I, in my code, could create a logging data source, right, that extends Oracle data source, right, like this. And I could, let's just do one because I don't want to do all of them. I could put, you know, logging before, and then var res, and then put it after, and then return the result, right? Exactly. So now in my code, I'm depending on a data source here, right? Well, if this is a new Oracle data source, then I'll get the version without logging, but this code doesn't change at all, does it? It's still a data source. And if I want the logging version, well, I can just swap that out, can't I? So it's still an Oracle data source. It'll do everything that Oracle's does, but it'll also have logging introduced. But this is a little tedious. If I want to add behavior to the code, I have to override every method and introduce it myself. And that's not fun. So what can we do to get the best of both worlds in this case? Well, we can use a sort of aspect-oriented programming, which is a trick where basically we in runtime programmatically extend your class. It's sort of like using reflection to extend your class for you and automatically doing it, right? So rather than you writing out the code, we can do it during the runtime of the program. And we do that by literally defining a new class for you that extends your class and then code generating the logic that you see here. So the result is exactly the same as if you did it manually. It's just much more efficient. And so we're able to do things like take your class and automatically make it an HTTP endpoint, or to start and stop a transaction, or to do logging, or to measure how long it's taken for a request to finish, or whatever. You can imagine all the different scenarios there. That's called aspect-oriented programming. We use it a lot in Spring, and it's based on this very simple concept called polymorphism. So that's three of the very important concepts. The fourth one is auto configuration. So before we can understand auto configuration, we just need to understand regular configuration. Over here, so far, everything I've shown you is not really tied to Spring, right? This is just Java objects that have relationships to each other. But if you want them to work in Spring, you need to tell Spring about these objects. You need to tell them how they relate to each other. So there's a couple of different ways. The easiest way is, well, first of all, let's comment that out, right? We're going to create a application context, okay? Application context. And this is what you would see in Spring Framework Classic, right? So I'll say context dot, I can say I'm going to give it this annotation application context. I'm going to point it to this configuration class, and then I'll say context dot get bean of type customer service. Okay, so that's a customer service just like before, right? You saw me doing that before, but now instead of instantiating this and then calling get customer service, I'm instantiating the context and asking it to hand me back this. And what is it going to do with this config application class? Well, sorry, we want to go back. It's going to be my config, isn't it? There you go. So what's it going to do with my config? Well, nothing at the moment. We have to make it work with that. So Spring has this idea of components, right? These are just objects that are managed by Spring. One of the component types is a class that provides other components. It defines other components, instances of them. And so I'm going to make this a configuration class, and I'll make these beans. So each of these methods produces a bean. The return value of these methods is a bean. And that syntax I showed you here, this actually works just fine. It's the same exact, you can do this in Spring, it's the same thing as before, but also, you can also do this, right? And so Spring is going to find the thing in the configuration, anywhere in the Spring application that has a bean type of data source, and it's going to give you that reference. It might be this one, but the nice thing about this is that you could also introduce it in other places, right? You might actually have different places where this gets resolved, but in this case, yes, the result is exactly the same. This will be this. Now, this is, of course, business logic code. I need the data source and I need the customer service. This is business logic. This is sort of just infrastructure. And this also is driven by somebody else's code. I probably, my example notwithstanding, I don't have access to Oracle's database driver. I can't change their code. So instead, I need to instantiate an instance of it. But I do have access to my customer service. So another thing that I could enable is component scanning, right? I can put this on any configuration class. And component scanning tells Spring to find all other classes that have @component on it. It can also find other classes that have other annotations that themselves have @component, like @service is @component. It has @component. So these annotations, they provide some technical distinction, but for the most part, the important thing to remember is that they are a function of the description of the type, not the technical feasibility or capability of that type. So this is a service in the UML sense. It serves. It provides business logic. Okay, and you also have these are called stereotype annotations, and we have other stereotype annotations for, let's say, HTTP controllers, right? Or for Spring, for data access repositories. So these are, very, very common annotations, but they are all themselves annotated with @component. We say that that's a meta annotation. And in fact, this meta annotation is there to provide flexibility. So you could create your own types, right? So we expect fully that you'll want to customize things. And if you do, that's perfectly fine, right? So you can get rid of that and we can put your component, and that will work exactly the same as if you had put regular component there. Okay, so these meta annotations give you control over the system, and since we've done that, we no longer need to define this. Okay, so we have half of our objects defined in this Java configuration class with a configuration annotation. By the way, this is at component as well, and we have some of our other objects defined by sort of by convention. We're telling Spring, okay, look for classes that have these meta annotations, these stereotype annotations, and if you find them, then go ahead and automatically construct a single instance of them. If they have constructors that require dependencies, these are other things that need to be provided, then look for other beans that provide that definition. Here's one that provides a definition for data source, and then pull them all together. And that's how you get the running state of your application. Now, this is, what I'm showing you here is Spring Framework. This is what's been around since 2004, since 1.0, and even a few years before that in a non-GA 1.0 format. And it's very, very powerful, but one of the things that's really come to the fore in the last 11 years is Spring Boot. Spring Boot takes this concept a step further, and it provides all these useful configuration classes out of the box, and it gives you hooks by which you can extend the default behavior. So for example, on the class path, we have a data source auto configuration. If you look at this code, this is just a regular configuration class, right? It's actually annotated with configuration. So it's a meta annotation. It's an auto configuration, which is itself at configuration. And we see in there, we have all these bean definitions, right? Well, we have a lot of other stuff in here as well, but ultimately, do we have them here? Here's one. We have a property. We have an object called properties JDBC connection details annotated with @bean. However, you might have noticed that there's quite a bit more going on here than just @bean and @configuration. We also have these conditions, these tests, and these annotations tell Spring when the application starts up to evaluate some test to prove whether the object should be created or not. Okay, and we have tests that look at things, for example, like whether this type is on the class path. If this type is on the class path and this one is on the class path, then and only then will this class get, constructed, and all the beans within it, constructed potentially. But this class is clearly not on the class path, so this will never run on startup. Okay. We have other annotations that say, create this configuration class, but only if there is no other bean of type data source or XA data source. And in this case, we're creating the configuration class. There's nothing inside of it, but that's okay because what we do have is an import. This import brings in other beans, right? Beans in this case for embedded databases, okay? So we have lots of ways to provide defaults there. We can look for the presence of objects, and if those objects are there, then we don't create ours, but if they're not there, we can give you useful defaults. That mechanism is called auto configuration, and it's what allows Spring Boot to do so much for you. It's convention over configuration, but unlike other convention frameworks like Ruby and Rails, if you decide you want to exert control over the code, you can just provide your own bean definitions and your own objects, and we'll defer to you and let you be in the driver's seat, where we do everything else that you want done, okay? You have full control, but we have a nice, well-honed, sort of well-tread path that you can follow that will get you to production faster. So in order to take advantage of Spring Boot, we want an application context still, but instead we use this convenient builder here called Spring Application.run. So when this code was generated for us from the initializer, we had exactly that, Spring Application.run. It provides an application context, right? The reason I'm not caching the pointer is because I don't very often need to get a hold of it anymore to get instances of the bean, right? You don't want your code to ever have to get to this point. So one way you can avoid having to write code in public static void main is to create an instance of a runner. So here's my application runner, which implements application runner. Okay, I'm going to add that to the constructor there. And this is just a callback interface. So if you implement application runner and then add that to your code, Spring, and let's make this a component, when Spring Boot starts up, it'll automatically call run, and it'll give you the chance to look at the public static void main string arguments and do something interesting with it. So here I could actually, instead of doing this, right, instead of actually getting a hold of the customer service there, I can just inject it into the runner like I just did for the data source, right? So private final customer service. There's that, right? So customer service dot blah. You can do whatever you want at that point. So the result is much cleaner than having to muddy up this public static void main, because remember, you don't want all your business logic to have to be aware of public static void main. The other thing that we want to do is we want to make sure that the Spring Boot application, is configured correctly. So we have this meta annotation here called Spring Boot application. Okay. So when you run this, it'll discover, Spring Boot application actually has auto configuration enabled. It has component scanning like we saw earlier, and it's got a Spring Boot configuration, which is itself a configuration class. So functionally, this annotation is similar to @enable auto configuration, component scan, and @configuration, right? So those three things are synonymous with that one annotation, but that one annotation is a meta annotation, okay? All right, so you might be wondering, where does all the auto configuration come from? Well, we have this auto configuration.imports files, and these are in the meta-inf directory of various projects, right? So if you want to see it, here it is. It's in autoconfigure, meta-inf spring, and then there's this text file here called org spring framework boot autoconfigure autoconfiguration.imports, and it's just a list of Java classes. That's it. Spring Boot starts up, it reads these files in all the jars in the class path, including yours, by the way. You can create your own, and it'll then instantiate, or at least try to, by evaluating those conditions and then invoking the bean methods. So the result is that you can have behavior that's automatically provided for everybody who uses your Spring Boot jar, okay? Okay, so we don't have all that much going on here, but let's just try it out, okay? So the application started up. You can see that because Spring Boot does quite a bit more than just create R objects, it also handles logging, handles, nice colored output. It handles timing and all that other stuff. It starts up an embedded web server. It's got very, very good ASCII artwork. Since it does all that stuff, the application started up lickety-split, but also it has a lot of other stuff beyond just the 5 or 6 objects that we've got here in play. So we're ready to build a real application. One common pattern you'll see in Spring, in the world of Spring, is the @enable pattern, right? So @enable auto configuration, @enable config server, @enable aspect J, or @enable load type weaving. This is how you tell Spring you want to opt in to a feature. So here, I'm going to tell Spring I want this code to be a Spring Cloud config server. Okay, so let's get rid of all this. I'm going to tell Spring I want this to be a config server, and it's going to be a REST API, an HTTP API that guards access to a bunch of configuration files in a directory. Which directory? Well, this one. It's a Git-based directory on my local machine, on my desktop, called config. Now, I could point this to a HTTP or an SSH, GitHub or GitLab or any other Git URL as well, but it just needs to be a Git repository of some sort. And in this case, the files in that directory are property files, very much like the same one that we're using here, that will correspond to the service that we're working with. So right now I have a service called Spring Application Name equals config, and the name is config, and so it'll load config.properties because of this. Other services, as long as they point to the same, they're going to talk to this config server, they will get, whatever, they'll get their property file that's named for them as well. Let's go ahead and start this up and see what we get. Okay, that's our config. It's working. What we're doing here is we're providing a configuration to help other parts of the system do its work. And they're going to get that configuration through their environment, right? So the environment, let's see if I do this. I create an application runner. I'm going to inject the environment that we just talked about. And that environment is itself, it's going to have a set of property sources, right? So I don't have if I configurable environment, if environment instance of configurable environment, right? Environment1.get property sources. This is a collection of property sources, and you can see that there's a collection of them, and that each property source is able to answer questions about, keys and values. So here's one, for example. No, not that one, different type. Property source, that's property source is, that one. Let's see, do we have the right one? This one. So this is the property source, and it's gonna answer question, hey, do you have a key called name? And if it's true, then usually the client can ask, okay, give me the key for that. Oh, this is property sources, give me a property source. There you go, that's the right one. So this will ask, do you have the key called name? And if so, then I can also ask, give me the key, give me the value for that key. And what do I mean by keys and values? Well, this is a key. This is a key. The environment variable called home, that's in your system shell, if you're on a Unix of some sort, will be a key, right? It could be any arbitrary string value that comes from the ambient environment in which a program executes. And so what we're doing by creating a config server is providing a central place to load configuration. All the other services that we build will have some auto-configured client that will talk to this and then fuel or answer requests for configuration via a property source that knows to look it up by talking to this REST API. Okay, this config server REST API. So let's see how that works in practice. This is running on port 8888. If I want to find the configuration for the microservice called service in the default profile, I go to localhost 8888/service/default. Note that at the moment I'm running this without any security or anything like that, but you can do that yourself, as per usual. You can also lock down the Git repository. It doesn't have to be wide open, as is the case here. So I'm going to get the properties from this desktop config folder called service.properties. Here you go. I've got another property file called application.properties. All microservices, all services, no matter what their name, will get the contents of application.properties, and they layer together. So first, all the contents of application.properties are loaded, and then overriding whatever in this, if there are any conflicts, we get the values from service.properties. Capiche? Okay, good. Let's move on. So we've got the config server. We are now going to need a database, aren't we? So we need a database, we need Docker, we need a whole bunch of stuff. So let me see. Do I have anything running? I do. I'm going to shut this down and I'm going to start from scratch, okay? So Docker RMF, there's that. Docker RMF, and then here's this one. And these are a Postgres and a RabbitMQ. I still need a Postgres and a RabbitMQ. So I'm going to go back to start.spring.io, and I'm going to choose Docker Compose, and I'm going to add RabbitMQ and Postgres. Now this is a pretty neat little trick here. You can actually get Spring Initializer to generate a Docker Compose file. Docker, of course, being a great way to create a Docker image, a container that you can talk to, like a lightweight virtual machine. So touch compose.yaml, emacs compose.yaml, and then paste that in. Okay, so now if you look at compose.yaml, it contains the definitions of a Postgres and a RabbitMQ. I want to actually open that up again and export the ports. I want to make sure that the ports are visible from outside. So 5432, 5672. Okay, good. Cat compose.yaml, and I can say docker compose up. There we go. So that means that both Postgres and RabbitMQ are running in the background there, waiting to answer requests. Postgres is a SQL database, RabbitMQ a message queue. Now I need to, give it some SQL and give it some data. And you know what? I have a file full of data about dogs that I want to load into the system. So I'm going to copy this from here. Dogs, that's my schema, right? If I look at this schema, that's the schema that I want to load. So I'll copy that to here. I'll call this schema.sql. And then I also have some sample data as well that I'm going to copy here. Okay. So let's now create a new program using Spring Batch. Spring Batch is a very, very nice little program framework that allows you to do sequential data access, to work with things like flat files, to work with like SQL databases and MongoDB, and anything that you might do large amounts of sequential data access. Batch processing is an art as old as time. It's been around forever, and it's the art of moving through different sources of data and processing it and then writing it out to another source, or another place. And this comes from the world of like batch processing, where you might have work that gets done at nighttime to allow people to use the one server, the one mainframe, in a multi sort of tenant fashion during the day. The batches of work would accumulate and they'd get done at one fell swoop at nighttime. And the world still runs on this kind of basic approach to technology, right? Banks and insurance companies and so on still use this concept of batch processing. And indeed, it's still very useful even in a non-legacy context, because you have all sorts of work that represents processing that needs to be done in the large. Okay, and so Spring Batch is just a godsend here. So let's go ahead and create a new microservice, going back to start.spring.io. And here we're going to create a batch application. We're going to use the config client. We're going to use Postgres, and we're going to use JDBC. Okay, I'm going to bring in the Spring, the Java database connectivity API here, and I'll call this module batch. Okay, and the config client, of course, is going to allow us to connect to the config server. So We're going to open this up and unzip it and open it in our IDE. First things first, we go to the config property file and we tell it to source its configuration from the config server. Which config server? Well, the default is localhost 8888, and that's, if you don't specify anything after that colon, it'll just assume the default, which works just fine for us because we are running it on localhost 8888. Okay, so this is our, and we can see we've got a config set here. So desktop config batch. Here's the config file. Okay, just close everything. There you go. So you can see we've got a connection to the data source, although I don't know that that's actually necessary because we have it in the application.properties in the root of the config. And we're going to tell Spring Batch to initialize schema and to this is schema for Spring Batch itself, and that's schema for everything. Okay. So let's go back to our config and just commit those changes. Okay. And now we're going to go back to our application. This property file will get read, but then thanks to this, it'll also read this. Isn't that convenient? So we'll have 4 properties in effect when we do that. So first things first, we want to tell Spring Boot to load the schema to initialize both, to initialize itself, but also to initialize our dogs table. Okay. Well, remember, I actually put a file here. I put dogs, go here, downloads, move dogs.csv to batch source main resources, and move schema.sql to batch source main resources. Okay. Okay, so both of these files are now within our context, and I want to tell it to load the schema here, which is just the definition of a table, into the database. Well, that's what that first property in the config server is telling it. It's saying load anything by convention that is named schema.sql or data.sql. This also tells Spring Batch to auto-configure its own database connectivity, its own administrative tables. You see, Spring Batch is really good at long-running jobs. You can imagine a job that takes 10 hours. Maybe you have to resize 1 million images, or you have to update, 1 billion rows in a table or something like that, right? And so imagine that process is running for, hours and hours and hours, and it gets to the last record, and there's some sort of corruption in the file, and it bails out. The program exits. Uh-oh, not good, right? But that means you have to restart everything if you weren't keeping track of where you were. Spring Batch will keep track of where you were. You can ask it, hey, how far did I get, and can I retry or resume from where I left off? And maybe fail that one little area that didn't work. Okay, that's called chunk-oriented programming. It's the ability to, do as many chunks of a given number, of a given interval as possible. And if you failed, then you just failed that one small chunk. So if you have like a chunk of 1,000, maybe you do, and you have 1 million records, maybe you do 1,000 at a time. And if something goes wrong, you've only lost 1,000 records. You can try, the other 999 tomorrow when you get into work. So let's go ahead and create a simple Spring Batch application to do that loading of the data from the CSV file into our SQL database. Let's confirm that SQL database is itself initialized. Okay, so if you look at this, we do want to connect to it. We want to see the database. You know what? Here, I'll use the console. We'll say pg password equals secret psql my user h localhost my database. Okay, there's the database. You can see it's automatically loaded this dog table for me, and it's loaded these other config tables that tell us and tell Spring Batch its own internal state. So, as the program runs, it's constantly updating its checkpoints into this SQL database. Okay, if we look at the dog table, there's nothing there yet, but we've got 4 columns: ID, name, description, and owner. So now let's go through and load all the data in the CSV file into that database. So the first things first, we're going to create a job. Okay, so this is a Spring Batch job, and it's going to be called CSV to DB job. Okay, and we're going to use the job repository. I'm going to say return new job builder, passing in, CSV to DB and the repository, and we'll say start, and we're going to pass it. It's called a step. So in the batch world, you have a job, and it in turn has 1 or more steps usually, right? So let's see here. What is that? There you go. Build, and voila. So that's valid, but we still haven't defined that step, have we? So remember, I'm defining a bean, and I'm gonna then inject a pointer to something called the job repository, which has been auto-configured for us, and a pointer to the step. Well, steps, you can have 0 or 1 or 10 or 1,000 or whatever. You can also do control flow. You can have one step execute, and then if it failed, then you don't fail anything else, or you can route to something else or whatever. So CSV to DB step. Each step has as its purview to read and then write something. So same basic formulation here. I'm going to inject this job repository. I'll say return new step builder. Okay. And we're going to create a job with a incrementer. This is so that we can run the same thing over and over without it like failing, because again, one of the things that is nice about having that database is that if you run a job and it's got the same parameters, that's to say, things that make the run unique, then it won't run it again. And that's bad because we need to be able to keep going on the same job. So we're going to have it automatically increment a number and then pass that in as the run ID each time. So that way it's unique, and that way we can keep going. Okay, so the step builder will have a chunk, and we're going to be reading data from the CSV file. I'm going to read it in as a dog object, okay? String name, owner, string description, okay? And that dog object, I'm going to read it in as a dog, and I'm going to process it and write it out as a dog, right? So it's going to be a chunk. What's the size of the chunk? Let's just say 10. I've only got 18 records. I'm going to need to manage transactions here, right? So platform transaction manager, there you go. And then I'm going to configure a writer, will come back, a reader will come back, and then that's it, right? So now you can see the basic shapes of this code. Let's see, oh, what else is required? The job repository. There you go. The basic shape is that we need a reader and a writer definition, okay? So each step has a reader, a processor, optionally, and a writer, right? And so they can read from anything. That the output of the read goes to the processor, and the output of the processor goes to the writer, okay? But we don't need the processor here. So let's do a empty stub item writer for now, okay? The contract is very simple. You're going to get a chunk of no more than 10 records at a time, and your job is to write it out. You can provide your own item writer, but the nice thing about Spring Batch is that, batteries are included. So we'll say flat file item reader dog, okay, that's this one right here. And we're going to create a new item reader that's going to read our CSV data, okay? So it's going to have one line to skip because it has a header file. It's going to have a resource, and a resource in Spring is an abstraction that allows us to deal with things that produce bytes. And there's there's many different implementations of resource here. You can see we've got abstract file, we've got byte array, we've got bean definition, we've got class path, we've got file system, we've got input streams, we've got servlet context. I mean, just innumerable many different implementations. And this is just a very minimal pared down class path. If you're using Spring Data for database access with MongoDB or whatever, there's probably a resource for GridFS. If you're using Amazon's S3 and you're using Spring Cloud AWS, then there's a resource implementation for S3. You get the idea, right? In this case, we're going to load the file called dogs.csv as a resource, okay? There's that. And then we want to also tell it a name. So we're going to call this dogs CSV to DB, okay? That's for persisting in the data store. And then the field set mapper is where we actually tell the code how to take a CSV field set and turn it into a Java object of type dog. We're also going to delimit it and specify the names. So let's look at that CSV file here. We have these as the names, okay? So let's just take that. I'll split it into an array. So we'll have an array with 1 item, 2 item, 3 item, 4, 5, 6, 7. 7 elements in the array corresponding to the columns of the CSV rows, okay? Now let's create a new dog. And we don't actually need all 7 rows, do we? We just want the ID and the name and the owner and the description. So field set.readInt ID, field set.read string name, field set.read string owner, field set.read string description. Okay, there's this. Add that, add this. Okay, so now we've got our dog flat file item reader. We're going to tell Spring to inject this, to make this available for injection over here in the configuration of the step. Okay, put that there. So dog flat file item reader. Let's just see if that works. We're going to print out just what we've gotten so far. So we'll say chunk.forEach and just print it out, right? If you expand this out, it'll take a consumer of type dog. So for each dog that we get back from the item reader, we would then want to print out the dog, right? So dog, good. Let's just run this program and see what that's bought us. Okay, look, it's worked. So we've got a bunch of dog objects, dog ID 97, Rocky, owners, null, it's empty in the CSV file, and description, okay? Now we need to write that out to our SQL database. So instead of doing this printout thing here, we're going to use a batch item writer, batch provided item writer for writing out to a database, right? So let's see, batch item, JDBC batch item writer, okay? Writing objects of type dog, okay? And this object is an item writer that works with SQL databases, so we need to provide it a pointer to our SQL database, which is auto configured for us. Okay, so let's get the basic setup here going. Got that. Okay, we've got that. We've got the assert updates, true. We've got the SQL, that's very important. We're going to say insert into dogs, ID name owner, ID name description owner, right? And what we're doing is we're using prepared statements here. So we're saying, we're going to ask the SQL database to compile the SQL query, and we'll just provide different parameterized values here each time. So there's four question marks and 4 values that it's expecting us to provide. Okay, and then finally we provide the item prepared statement setter. Okay, there's that, right? We're going to say prepared statement dot set int is 1. That's the first question mark. It'll be item.id. The second value, the second question mark, will be, what is that? Name. The third will be the string. Okay, and obviously I'm using the wrong types here, so set string in both cases. Okay, and then finally the fourth one will be item.owner. Okay, all right. So if we've done this correctly, then Spring Batch is going to automatically call this item prepared statement setter each time it's trying to write a row to the database for us. Okay, and now we've done this, let's tell our step about that result. Okay, and we'll replace this inline version with the one that we've just configured. Okay, let's see if that works. So remember, we have no data in the dog table at the moment. Let's restart this, and something has gone wrong. Oh, dogs insert. Okay, so my SQL query must have been wrong. Okay, there we go. There's our 10 records, or sorry, 18 records that have been written out to our SQL database based on Spring Batch. So Spring Batch is a great way to do batch processing, and I've just showed you a very, very simple example with a very simple flow, but you can imagine doing very, very sophisticated things with that. Okay, let's get back to our sort of main business service, okay? What we're going to do is we're going to build a service, which is to say an API or a front end or, sorry, a back end service or something like that, and we're going to call it service because I'm great with names. I get that from my dad. My dad was great with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Again, amazing with names. Okay, so there's the service, and we're going to have a fairly substantial number of things here. Okay, Spring Web, the reactive web support. We're going to add AMQP for RabbitMQ. You could use Kafka, it doesn't matter. Config client, Postgres, gRPC. This is the experimental Spring gRPC project, but it's, fast converging towards awesome. Dev tools to make it so that we can do live reloads. Spring Modulith to support modular code bases. Spring Data JDBC. We want OpenAI for AI support. We want GraphQL. We want the resource server, GraalVM, Actuator, and of course Spring integration. Okay, so that's a fair number of things there. Let's hit generate and open this up in our IDE. Okay, first things first, we're going to set up the configuration. So we'll go to the application.properties, here, config server. Okay, it's going to load the configuration for service, right? And we can see here, if we open up service.properties, that we have security. We'll look at that in a bit. We have a graphical console, and we have some stuff related to Spring Modulith. And also remember, the database and the RabbitMQ connection are defined in application.properties, as is virtual threads and the actuator. So these are all in play for every app that we build. So we have already a database in this service. I want to make it so that we can work with this code base a little bit easier to begin with. So one thing I'm going to do is I'm going to move us from Spring gRPC 040 to 050 snapshots. In order to do that, I need to have the snapshot Maven repositories on the class path that are available to me in the build. So I go to start.spring.io, I chose a snapshot version. It configures this for me. I'm just going to copy and paste that here to the bottom of my build just to make it easier. And then I'll use the version of Spring Boot that I want. And you notice that Spring Boot does a lot of stuff for us, right? Even the Maven dependency management is a lot easier. I have a very small handful of versions. Most of the versions of the dependencies are managed by Spring Boot itself, so I don't have to worry about remembering what version of what lines up with which. So 050 snapshot, okay. Command-Shift-I and IntelliJ will reload the build and pull in the extra new version. The other thing I don't want to do right now is to deal with security, because I need security, but for now, just allow me to iterate a little bit more effectively and talk to the server. I'm going to comment that out so it's not stopping us from hitting HTTP endpoints in the code. Now, I'm going to try and build a modular code base. When I say modular, you know, it's a code base that is written in such a way as to limit the blast radius of change. So I'm going to create a new package which lines up with what I want. I want an adoptions package, and I'll create a dog adoption service therein. Notice that this type is public by default because of IntelliJ's, you know, templating settings. It should not be, right? By default, when you create a class in Java, it's not public, right? That's what the Java language designers intended, and I think it's a great default. In fact, you should strive for that. I challenge you, go through your code base, you know, in a branch, surely, and try removing the word public. If everything breaks catastrophically, then you've probably been structuring your code incorrectly, right? Things should not all be intertwined so much that that removing the public keyword breaks everything, right? And one way to avoid this is to avoid what I consider to be an anti-pattern. If you have your code structured like this, app.controllers dot, right, app.services dot, app.models dot, app.repositories dot, etc., then that's probably a bad sign, right? Imagine how this would have to work. Imagine if I have an entity called customer. In order for me to have a customer repository, this needs to be public because it needs to be, I need to depend on it here. And then likewise, in order for me to depend on the repository in the customer service, this needs to be public. And then for me to depend on the customer service within the customer controller, well, you get the idea. The customer service needs to be public. And this is really, really bad. It's much cleaner to instead say app.customers, right? There you go. And you can put all that stuff as package private types in there instead. It's much more clear to those who are looking at the code what goes where and what does what. It's also easier, should you decide that this customer's functionality is becoming worthy of its own service, to just pluck that one package and drag it into a new folder in a new, you know, new Spring Boot project rather, and then just start that up. You're in a good place. So you want to be very deliberate about what types you make public and advertise to the rest of your code base, because that might be a link or dependency that somebody else can depend on that you can't break anymore. You can't refactor, you can't change, and so it's a liability, okay? Reduce the blast radius of change. And by the way, this is not a technical concern. I mean, I'm telling you technical things, but the reason we pursue modularity is to avoid creating unwanted dependencies or interlinkings between different parts of the organization that you're working in, right? If you have to have a long meeting to synchronize and collaborate on every single refactor, that's a problem. Better to avoid the possibility in the first place, okay? So we have a new service that's going to handle adoptions. So let's just flesh out what that looks like. We're going to be able to change the owner field in the database for a dog given its ID. We want to return a collection of dogs, but what dog? We don't have the dog type. So let's just, you know, we'll leave that red for a second, okay? And then we want to also, maybe we want to support people who want to ask questions about prospective dogs, right? So we'll support that as well through an assistant, like a chatbot. Okay, well, we clearly don't have a type, and I'm going to use here Spring Data JDBC to make it easy to do sort of updating and working with my database, okay? So I'm going to describe a Java object that maps to my domain. It'll have a string, owner, and a description, and a name, okay? And I'm going to tell Spring Data JDBC that this is a managed object, and the object, the parameter, the value in the object that corresponds to the primary key should be annotated with @ID. Then I'm going to create a repository, and this is a very common pattern in Spring Data. Well, Spring Data is a huge umbrella project that has implementations for JDBC, for JPA, for MongoDB, for Neo4j, for Redis, for Couchbase, for just any Cassandra. Anything you can imagine. There's a Spring Data repository implementation. So I'm using a generic list-CRUD one, but you might have a Cassandra repository or Neo4j repository or whatever, depending on your need and which projects you have on the class path. And these base interfaces provide convenience methods like find all, find by ID, save, update, delete, count, etc. Obviously, I need the basics here, but you can also create your own custom methods. You can say find by owner. And because this is just an interface, you don't have to provide the implementation. When Spring Boot starts up and Spring Data starts up, it's going to find this interface and it'll automatically create a Java object that subclasses, that implements this interface for you, and it'll provide an implementation of this method that does what you want. It'll say something like select all from dogs, or I guess it's just dog, isn't it? Where owner equals this, and that's the parameter, right? So you can exert control of that by providing queries and so on, but my point is you get a lot from Spring Data just by the defaults, okay? That'll be good enough for us. So let's now plug in that dog repository, like so, into the constructor, and let's flesh things out. So first things first, this one's easy, right? Find all, done, easy. What about this one? Well, we want to say dog repository find by ID, and if the object is there, then we want to take the object and update it, right? So we'll say new dog.id dog.name. We'll take the owner from the parameter that the user gives us, so that's the thing we're updating, and then we're going to save that out like that, okay? And in fact, you might even argue I could just inline it, and I probably should, okay? It's cleaner. Good, and now I can announce that we've updated it. All right, so that's better, much better, okay? And we'll come back to this, surely, okay? Don't worry about that. We'll come back to that in a minute. Let's, how do we try this out? Well, we need to create an HTTP endpoint, but before we get to that part, I'm looking at this code and I'm thinking, it works, I guess. It'll probably work, but it doesn't seem very realistic. For example, in a more real example, I might have another package called vet, because you can't just take possession of a live animal in most jurisdictions by just updating one column in one database table somewhere. You might have to schedule the animal for a checkup at the veterinarian, for example. So maybe I have a vet. No, I'm sorry. It's a class. A veterinarian is a doctor for dogs, so we shall call it Dogtor. Okay. So maybe I have a service, another service over here, and another. We're gonna, it's a root package. It's a package adjacent to the root class here. So we call that a module, okay? Let's say I have another module, and it's got a type called Dogtor, and it's going to have a method here called checkup, and I'm going to check up on the dog ID, right? Well, I can say checking up on dog ID. So that works. I could actually inject that over here, no problem, right? Dogtor, and I could private final Dogtor, right? I can do that, and I can add this to the constructor, and I can down here, I can say, okay, updated, and then I can say dogtor.checkup, and I guess that would work, but this seems like I'm creating unnecessary tangles between parts of the code base. First of all, I need the checkup to be done, but I don't need the result of it. I don't actually care. It's void after all, right? There's nothing I can do besides invoke that checkup functionality, right? This is void. So that tells me I don't actually care about the return value. So why do I even care about directly invoking this in the first place? And also, this is not necessarily part of my business logic. It's just an orthogonal thing that needs to happen, but not necessarily on which I'm dependent. So let's instead make this not public and see if we can find a way to integrate these two things to make sure that they both happen coincident with each other through the use of messaging. And you might be surprised to know that Spring actually has, in Spring Framework, something called an event bus, an event publisher, application event publisher. And that leads us to the question, which event? Well, we're going to create our first deliberately public type. It's going to be called dog adoption event. I'm going to put this in the adoptions package, and it's going to have dog ID. Okay, so now we can go here, and we're going to say application event publisher.publish new dog adoption event. Okay, so now that's going to get published, and then we'll print out this. And we want to make sure that it gets processed over here when we say event listener dog adoption event, right? So that's pretty good. The thing that's kind of interesting though is that this will run in the same thread as the thread where the message was published. And so if you're expecting the adoption to finish immediately and then separately in a separate thread, this checkup to happen, well, you'll be sorely disappointed because this is going to take 5 seconds and that's going to stop the main thing, which is the adoption, from proceeding until this finishes. And again, I don't care about the outcome of this. I need it to happen. It's a fire and forget operation. I need to guarantee that it happens, but I don't need necessarily the result. So how do I make sure that this happens in a separate thread? Well, I could do @async. But remember, this puts it in a different thread, and if you were relying on being in the same transaction in this logic as you would have been in the first thread, in the first class, the first component, then you're no longer in the same transaction. You could create a new transaction like that, or even better, put it here on the method. But honestly, I think this is not probably what you want, because you'll have one thing that has a transaction that commits, and then another thing that starts a new transaction. But if the second thing fails, that doesn't roll back the first thing, right? You don't get a guarantee that your system's in a consistent state. So it's much better to make sure that even though the first thing is finished, that we have some way to guarantee that the second thing finishes. So we're going to look at a nice feature in Spring Modulith called Application Module Listener. This pairs very nicely with these other features that we looked at earlier to republish outstanding events on restart and to initialize the transactional ledger for these outstanding events called whose schema will be defined by Spring Modulith. So let's try that out. Okay, so we've got the updated code, we got the configuration. I'm going to now create an HTTP endpoint so that we can try all this out. Okay, a very simple HTTP endpoint. Okay, so this is a dog adoption HTTP controller. It wouldn't be hard to make this a proper RESTful thing, but it's not right now, so I'm not even going to bother with the REST controller annotation, which is a stereotype annotation. So I'll say post mapping dogs dog ID adoptions. Okay, and here it'll be the path variable. That's the dog ID. This is there, and we're going to have the request param, and the param will be the new owner name. Okay, so we'll say dog adoption adopt, voila. Okay, there we go. And that's what we're doing. We're calling that method and that URL with that parameter and another parameter with a name, and we're passing that to the service, which will then update the database and publish an event. Oh, interesting. We've got this injected twice. Let's just clean that up a little bit. Okay, so that should be much better, right? Let's go ahead and, we can also verify everything else is working. So if you're doing HTTP, you have verbs like get and so on. Get, post. Post is a great way to write things. Get is a great way to read things. And of course, we'll need a assistant endpoint here soon enough. It doesn't do anything yet, but we can actually delegate to that and make sure it's done. And then this will be a request parameter, string question. Okay, fantastic. Okay, let's restart the HTTP controller and see whether it's working or not. Okay, HTTP, we can use a syntax shortcut here, dogs, and we'll use dog ID 45, adoptions. Okay, so if you look at the table, the database table, where is that table? Here we go. You can see that Prancer is a very peculiar dog. His name is Prancer, his ID is 45, and he's described as a demonic, neurotic, man-hating, animal-hating, children-hating dog that looks like a gremlin. Okay, so we'll do that, and let's see, over here, dogs 45 adoptions, and the parameter was called owner, so owner equals JLong, and it's going to be a post, and I'm going to do form multi-part encoding, right? Post that, and you can see it says updated. It returned immediately, which is nice, but we're waiting 5 seconds for it to say checking up on. Okay, great. So if we go back to the table here and select all from dogs, you can see that now, this time, the owner column is not null. Great. So let's try this again. But notice that also we have another table here called event publication. So if I look at event publication, you can see it's published, it's created a log, a transactional log of the event that got dispatched from one module to another. So it's got the ID, the the listener ID, which is dog.checkup. It's got the event type, which is a dog adoption event, the serialized representation of the event, the publication date of the event, and the completion date of the listener once it's finished. Well, obviously, in this case, the listener did execute successfully into fruition, but what if it hadn't? Let's try that. So we go over here, post, you can see it's saying it hasn't finished, and it's finished now, right? So if we go back here, it's finished, okay? So one more time, run that, This time I'm just going to stop the process. Good. So now if I go back here, you can see that we've got an empty value where there should be a completion date. So now we're going to restart, and what we should see is that Spring Modulith will retry, it'll replay that missed event, and it'll automatically, complete it for us. Okay, let's wait for it to print out. There it is, checking up on dog adoption event. And now we can go here, select all from that, and you can see it actually finished asynchronously, eventually consistent. Okay, this is called the outbox pattern. Whenever you have some transactional state that you want to manage, if you have non-transactional state that you want to manage, you can reconcile it against a transactional resource like a database table. Okay, so here we're making sure that the thing that may fail and that has no transactional state, we're making sure that the thing that may fail and has no transactional state, like publishing a message from or an event from one module to another, gets handled eventually. So far, I've been publishing a message from one boundary to another, from one module to another. And I think my code is modular. It feels modular. But how do I know if it's modular? Well, same as anything, right? You write a test. So let's go over here and set up a quick test. Var application modules.of service application.class. And we're using the Spring test framework. Obviously, this is code generated for us by the Spring initializer, but it's a very convenient way to get a Spring application context up and running and giving you access if you wanted to. You could, for example, say auto-wired and then inject, the dog repository or whatever public types you've got, you could inject it here. Or you could put this in the same package and that would work as well, right? So if I can inject the data source, right, for example, and that would be the Spring managed data source that we have, and I could use that. So this is very convenient, but it's otherwise just regular JUnit. In this case, we're going to verify that the structure of our code is actually modular, that we haven't inadvertently leaked something from one module to another. Since Spring Modulith knows about the structure of the code, we can also print out and enumerate that state as well. Here we go, write documentation. Okay, the test is green. I love it, love to see it. And you can see here that Spring Modulith knows about the logical structure. It says adoptions and vet, and here's the dependencies within that code, right? Very, very convenient. So that's worked, okay? It's worked, and it's actually even nicer. It's generated a folder here in the target directory called generated source, Spring Modulith docs. And here you can see plant UML diagrams that give us C4 architecture diagrams. So this is very nice and much better than the status quo where you look at a wiki page and find some architecture diagram that represents the state of the art of the system from like 2 years ago. This is actually, it evolves with the code itself. So it shows us the component boundaries. This style of architecture diagram is called the C4 component bound diagram, and it's created by my friend Simon Brown. Very, very convenient. So this is nice. Now, we've been publishing and we've been working with modularity here, and the tests are telling us that our code is modular, but this is all in the same JVM. Sometimes you might have to integrate other external services. Okay, so in this case, Spring Modulith has your back as well. It supports what's called externalization. So let's go back to our code here, and we're going to externalize this event. Okay, externalize. See that org Spring Framework Modulith events, and then we're going to provide a string in here so we can externalize. Okay. So we can add the annotation called externalized and provide a string that helps Spring Modulith determine how to externalize it. It's sort of like a little schema, a little DSL within itself, and it depends on which adapter, which binding you are using to support externalization. We're going to use the support for Spring integration. So Spring integration is a messaging and integration technology, and it works based on the patterns in Gregor Hoppe and Bobby Wolf's amazing book, Enterprise Integration Patterns. So we're going to provide the name of a message channel that will conduct the message externally to a Spring integration flow. And from Spring integration, you can use anything you want. You can use Kafka, RabbitMQ, you can use JMS, you can use Amazon SQS, you can use file systems, FTP, you can send an email, you can tweet, you can do whatever you want, right? So there are other adapters that are focused. There's like a focused externalization support for Kafka and for RabbitMQ, for example. But I happen to like the Spring integration support because it's just a one size fits all. From there I can go anywhere. Okay, I can send a WebSocket message, for example. So we're going to say outbound adoptions message channel. In order for this to work, though, we need to bring in the specific support for Spring Modulith and Spring integration. So let's add this. We're going to say Spring Modulith events messaging. And you can see all some of the other many different supported versions out, that are in there by default. We're going to add this, and that's going to give us the bridge between Spring integration and the Modulith subsystem there. Go back to the dog adoption code, and we have to make sure to define a message channel. That's like a pipe, a queue through which messages will flow. So let's just define that, I guess, here. We'll scroll down. Maybe I better yet, let's just put it at the top. Why not? Configuration. We're going to call this integration configuration. Okay. I'm going to create a message channel like that. I'm going to say message channels dot direct, and it'll be a message channel spec like so. Okay, so this is a message channel that Spring integration will use. It's a pipe. You can line it up so that things get put in the pipe and then things on the other end can listen for the data. And it supports the, guess what, pipes and filters architecture. Okay, so this is named, the method is named the same as this, right? If you want to be explicit about that, you could have a static final string, adoptions channel name equals that, right? And you can say adoptions channel name, and you can go back to the externalization annotation, dog adoption event, and plug that in. Right? So we go here, and it'll be integration configuration adoptions channel name. So now it's the same thing in both places. No magic strings to worry about, or at least there's only the one. You don't have to worry about it falling out of sync. Okay, fantastic. So now we've got that. What's going to happen once the message arrives in the channel? Where that channel at the moment is kind of a dead end. There's nothing on the other side doing anything with it, so it'll fail. So what we want to do is configure a Spring integration flow, okay, to listen for the messages coming out of the channel and then doing something with it. In this case, we're going to send it to a message broker, and that could be Apache Kafka, it could be JMS, it could be Kafka, RabbitMQ, it could be whatever you want. We're going to use RabbitMQ because, again, we've already done the work to spin it up, right? We have this Docker Compose file with RabbitMQ running on port 5672. Okay, so integration flow, outbound adoptions integration flow, and we're going to say integration flow from, and we're going to take this channel here, so message channel, and we're going to inject it. Now, by default, if you only got one bean of a particular type in the context, Spring will inject just the one. It doesn't matter what the name of the variable is. But in this case, Spring integration will automatically have at least 2 or 3. So we want to make sure that we get the message channel that has the same name as what we wanted. One way to guarantee that is to take the method and then do that, right? That would help. But if you want to be very sure, you could just say, like, what if I just did that? It'd be a shame if this broke just because somebody refactored this. So instead, I can use a qualifier annotation, okay? And this is also a nice place to have that adoptions channel name. That tells Spring to find, of all the possible message channels, to inject only the one that has that bean name, okay? So we're going to say from the message channel, we want to send the message outbound, okay? So from the channel, we're going to send it outbound using a handler. And we're going to use the Spring AMQP outbound adapter, okay? So here's the DSL, Org Spring Framework Integrations, AMQP.DSL, outbound adapter. And we have to provide an AMQP template, okay? So AMQP template, and we're going to specify a few things here. What's the routing key? Well, in RabbitMQ world, when you send a message, it's a binary protocol. It's not tied to Java. You can use RabbitMQ with any other language, any other technology. And the protocol specifies the concept of an exchange, which is where messages enter the server, and then a queue. So the exchange decides where to send the message within the RabbitMQ bus. That's like the door into your server. And then once you go inside the door, where do you go? Left, right, straight? That's the exchange job, right? And once the message has been exchanged, it has to route it somewhere. So then it sends it ultimately based on some heuristic to a queue. And so in order to sort of inform that process, you can send a special header, like there's a message body and headers that get included in the message sent to RabbitMQ. And one of the very special headers is called the routing key. Okay, so we're going to create a private, I guess, static final string, whatever, adoptions name, and we'll use this to be consistent. Okay, so routing key, and we want to send it to the exchange also called adoptions name. Okay, so that's very convenient. it'll get sent via this integration flow to this AMQP outbound adapter, okay? And then it'll be sent to the other service, okay? Or to the broker, where it'll be consumed by another service. The problem is, at the moment, our broker doesn't have an exchange called adoptions. It doesn't have a queue, and there is no link between that binding, that exchange, and the queue anyway, because nobody's defined it yet. One of the nice things about the fact that RabbitMQ is based on a protocol is that you can define all that stuff yourself in code, be it Java or any other language. It's just a network protocol. You can administer the data structures in the RabbitMQ broker via code. So I'm going to use Spring AMQP, which is, remember, AMQP is the protocol that RabbitMQ speaks. I'm going to use that to define some of the objects that I need in my RabbitMQ broker. And there's a nice definitional way to do that here in Spring, and thanks to Spring AMQP. So let's do binding. We'll say adoptions binding, okay? Binding builder. I'm going to bind a queue to an exchange. So we'll say queue, org Spring Framework AMQP core, adoptions queue, return queue builder dot, there you go. And we want to bind it to an exchange, right? So again, exchanges are the ingress that allow things to enter the system. So exchange, adoptions name. To keep things simple, I'm just naming everything adoptions, okay? So adoptions queue and adoptions exchange, and we're going to bind the queue to the exchange, okay? Adoptions queue, and then binding it to adoptions exchange. We're going to say if and only if it has this routing key, and the routing key, of course, we specify down here, is it also adoptions name, and otherwise it's going to be a no args exchange binding, okay? Okay, so I think that'll give us most of what we need. Oh, whoops, I bound the same thing to the same thing. You can't do that. So I want to bind that to that, looks like. There you go, much better. So that key will be bound to that exchange. Okay, so we're, I think, in a good place. Spring integration will start up as soon as we publish the message using our, HTTP endpoint. It'll publish a message via the application context event publisher, the application event publisher, which will in turn trigger Spring Modulith's amazing externalization support, and that'll publish a message to Spring integration, which will then publish it to RabbitMQ for us. So now both, we're going to be publishing a message from one module to another and externally to other services and beyond. So let's go ahead and restart this service. And before we actually try it out, we need to have something that listens for those messages in RabbitMQ. So let's take a brief digression from that code and go back to the old Spring initializer here. And we're going to create a new module called integration. This will use, you guessed it, the config client, Spring integration, and of course, JDBC, we want AMQP. And I think that's basically it, right? So we'll hit generate, open this up, UAO integration.zip. Okay, there we go. We'll say config import config server. And in this code, we're going to create an inbound adapter, sort of the reciprocal to what we had just done on the other side. So integration flow, inbound integration flow, and we're going to listen for data coming off of the RabbitMQ broker. So from, I'm going to use var AMQP equals AMQP.inbound adapter, and we're going to point it to the connection factory, which is the auto-configured connection to the broker that Spring has automatically created for us, okay? And oops, we'll put that here, and I guess that's it, actually. Anything else? And then we need to specify the queue name, which is adoptions, as we know. Okay, there we go. And we're going to say from AMQP, then what? Well, we want to handle the results. But what are the results? Well, by default, the results are a collection of bytes, right? And so let's just try that out. Let's just, print out the results, a new string bytes, and we're going to print out all the headers that come with the message as well. Okay, so what is this? Oh, a new by consumer, so it's going to have key and value. Okay, and I'm going to print out this plus that. Okay, good. Okay, so there's the updated code, and of course we can make that a lambda as well. Let's try this. Okay, that's up and running. Here's our config, our batch, our service, and we're going to make a call and see that when we try and adopt the dog, it'll publish an event which will get published to the integration module. Let's go over here, publish that, updated this, and you can see over here we got the payload is a string, and it's the JSON serialized representation of the object, and all these very interesting headers that tell you things about how the message got here, you know, the ID, the unique ID, the content type, all that kind of stuff that we might need on the other side to understand what to do with this. What I want to do with it in my Spring integration code is to turn it back into a Java object, right? So I have dog, int dog ID, and you know, I guess that's all I have here, right? It's not a very complicated Java object, but it does count. So I'm going to transform it. I'll say transform new JSON to object transformer, okay? And it'll be transform new JSON to object transformer. And the type that we want to transform it into is dog. And then we're going to, there we go. So now by the time it gets over here, it won't be a generic handler of bytes. It'll be dogs, right? That's the nice thing about this, is that we can actually, you know, the output of one step is the input to another. This is a chained workflow, right? So I'm just chaining the processing here. And the nice thing is that you can write nice, simple sort of Lego brick-like code where you write code in terms of the absolute minimum that you need. You have preconditions and postconditions, and you can swap these things around as long as you maintain the preconditions and postconditions. Okay, so now I'm going to, you know, we know what it is. We're going to turn it into an object first. Let's see if that gets us a better result. Okay, same exact flow otherwise. We're just transforming it before it gets to us. Okay, and there we go. We got a Java object being printed out, a record very clearly. So that's nice. But what if I also want to write this out to another system? Maybe I want to put it in a file system or send it somewhere else or whatever. Let's just do a simple example. I'm going to write it out using Spring Integration's file support. Okay, so I can go here, Spring Integration file. Now, I don't know, you know, there's all sorts of file systems out there in the world, FTP, SFTP, NFS, you know, Samba, whatever. So we use Spring Integration's venerable file systems support because you don't really need an extra service to set it up and try it out. So we'll say file, outbound adapter. I'm going to write it out to a directory. Which directory? Well, we're going to have Spring create a resource for us. So on the desktop, /outbound, we're going to inject a resource, throws an exception, and the file will be resource.getFile. Okay, and we're going to just pass that here. Okay, so now we restart, and oh, whoops, we can't. We have to tell it to first of all create the outbound directory for us, which we're not doing. So, and you know, auto create directory true, but also we need to specify the payload, right? And it can't create a file if the object is a Java object. So we need another transformer. So it's actually quite fortuitous that that failed. So we're going to say new object to JSON transformer, object to JSON transformer. Again, you know, and in this case, you know, we don't have to provide a parameter. Take it again. What's the issue now? Oh, the directory doesn't exist, right? It's not a valid URL. So file, there we go. Okay. So now post that, and we don't have the result yet. Did I restart it too quickly? There we go. Dog ID, all that. And now go to the outbound directory here, and there it is again. There's the file, right? If I go here, there should be 2 files, 3 files. You get the idea. It's taking the message from the service, sending it to RabbitMQ. On the other side, we have a consumer listening for the data from RabbitMQ, printing out some information about it, and then writing out to the file system. You can control everything about every part of this flow, but it is very powerful, and it's an example of a pipes and filters architecture. You can do things like filtering, you can do splitting, and fork join where you send data and consume it, and so on. Okay, so now we have a nice integration flow handling adoptions for us. Let's go back to our main service, get back to that, and here, what I want to do is integrate AI to help us flesh out that assistant that we're building, right? So I'm going to say dog adoption service, and I'm going to go to this dog adoption service method here. I'm going to use the Spring AI chat client. Now, Spring AI is a framework that you need, and I think in every app these days, to do and to work with AI, right? And so we have a chat client. This is a kind of like a JDBC client or a REST client. It's a fluid way to talk to a model. Which model? Well, that depends. In this case, we have Spring AI's support for OpenAI on the class path. And OpenAI is one of many different choices. There are different models that you can use. Some are local, some are hosted, some cost, some don't, but you can talk to all of them via Spring AI. It'll provide the auto configuration for the chat model on which your chat client will automatically be configured to depend. So let's create the chat client and put in the details there. There we go. Okay, chat client. Okay, And now I can inject that chat client here. That's what I've done here. And I can then use it to give it a prompt, which is the user's question, passing that in, and then calling it and getting a string back in response. So if we go back to our post endpoint here, the assistant has a parameter called question. So assistant and then question. So you can see the service auto reloaded. Let's go ahead and now do assistant. Okay, and then question is, how do you deal with neurotic dogs? Okay, simple enough, but it didn't work. Why didn't it work? Assistant question. Oh, it's a get. That's not going to be a post. Okay, so we just need get. Okay, wait for that response. Takes a little while because it's chatting with a model. Okay, so we got a little book report here saying, hey, dealing with neurotic dogs can be challenging, but there are several strategies you can employ to help them feel more comfortable and secure, blah, blah, blah. Good stuff, obviously. We could do a lot more here. We could do a retrieval augmented generation where we get data from a database and then send that to the model for analysis. Lots of other patterns here. You can build MCP services and do agentic kinds of services, all with Spring AI. It's a very, very powerful toolkit, but our job is done. We've done what we needed to do with that, so I'm happy with that. One question that might come up is, say, does that long duration that we just saw to make that request, like, does that have implications for our scalability? And yeah, it does. I mean, if you have a request outbound going to the downstream service, yeah, that's going to take a long time, right? And that takes a time, and when it executes, it runs on a thread, right? And it's running on the same thread as the rest of our, it's running on one of the same threads as the rest of our system depends to handle incoming requests. So the longer you sit on that thread just waiting for bytes to come back, the less scalability you have. There is, it's very important to keep in mind that threads are your channel by which to access the CPU. If you sit on the CPU and if you sit on a thread and don't use the CPU, which is exactly what's happening here when I make a request over the network and I'm just getting bytes back and forth, but I'm waiting, I'm not doing any processing really for whole chunks of time, then I'm wasting that thread. And so the question is, can we have our scalability cake and eat it too? And thanks to Java 21 and later, and again, keep in mind, Java 24 is almost here, we have support for virtual threads. So what we're going to do is integrate virtual threads into our code. And actually, you might have, the student among you will probably recognize that we've already done that, right? Here's how you turn on virtual threads in Spring, right? You say spring.threads.virtual.enabled equals true, and that's it. And it's kind of fun to see this in action. So I'm going to create a simple demo back here at the initializer. We're going to call this VT for virtual threads, okay? I'm just going to add the web support here, and we're going to try something out. This is a demo that I'm stealing from my friend and colleague Cora E. Berkeley, okay? And the demo is very simple. We're going to have a simple HTTP controller, Spring MVC controller. I'm stealing her demo, right? That will call a downstream service, and that downstream service is designed to simulate delay. So let's build up a REST client. Okay, use that, and we'll say when somebody goes to delay, and we're going to run, this is not a, we don't have any config for this, we'll just run this on port 8083. When somebody goes to 8083/delay, we're going to call the downstream service. We'll say RC, I guess we need to make this REST client, make it a little longer so that IntelliJ knows what's happening. Okay, .get.uri, http-bin.org, delay 5. Okay, retrieve, get the body back, string.class. Okay, so there we go. We're going to make a network request, and this endpoint that we have right over here is going to block. It's going to simulate a long-lived request that'll take 5 seconds to produce a response. So we're going to sit here unnecessarily just waiting for a response to come back. Eventually it does come back, but it takes forever. So that simulates sort of the kind of delay that we got when we called that AI, OpenAI endpoint, right? And when you call other microservices or when you call a database or whatever. And this is by default, as configured right now, since we're not talking to the config server, this has no virtual threads, okay? So let's go ahead and start up this application. Go back to the console here, and we'll say HTTP 8083 delay. And let's just see, you'll see that even though I'm calling my own service locally, it's going to take 5 seconds and some change to get a response because it's in turn using our REST client to make a call to that actual network service. Okay, so we got the response back eventually, but it did take 5 seconds, right? Okay, now let's do some load testing. We're going to use a load testing tool called Hey, and this is going to just barrage our service with a bunch of requests. But the problem is we have a lot of threads on my local machine. I have a very, very powerful machine. So do you. I mean, basically all of us too. But that's not representative of the machine you might find in a production environment. So what I'm going to do is I'm going to limit the number of threads I have just to 10 to force some contention, right? I don't want Tomcat to have too many ways to handle this traffic. I want to limit the number of threads to simulate the kind of load or to simulate the kind of contention you get under severe load, okay? So now let's do hey 40, and then concurrently we're going to do, as many as 20 requests. So it's going to make 40 requests, and then it'll do as many as 20 at the same time. But remember, we've only got 10 threads, okay? Oh, I have to do the full URL, right? This is not HTTP. So, okay. So this is without virtual threads. If you've ever used Hey, it's sort of like Apache Bench, AB, which also lets you sort of shoot off a bunch of requests to simulate load testing. Okay, so we got back all of the requests. We had no errors, no 500 errors down there. Let's log the results here. Yuck. Okay, I'm going to say yay. Now we're going to do the same thing with virtual threads. And again, we just have to enable them like this. Okay, and now we do the same exact test. Okay, we got 40 responses back. But with virtual threads, you can see that the situation is very different. With virtual threads, the total time for all 40 requests was 13 seconds compared to 22 seconds. So that's, just slightly under 2 times faster, right? 2 times, it took almost half the amount of time to handle the same number of requests. And remember, each request should take about 5 seconds. It should be 5 seconds plus whatever network latency you've got. And in this case, it took about 6 seconds with some contention for the slowest request to get handled. But over here, since we had a lot of contention, it took almost 4 times as much time, to get a response. It's almost 20 seconds. It's just 3 seconds shy of 20 seconds. So, and then the fastest was about 5 seconds in both, a little bit over 5.01, just under 5.01 seconds for both. So, they're on par. Maybe, I'll be honest with you, in theory, this one should be slightly faster pretty consistently, just slightly, because there's a network overhead. There's the overhead, not with the network, but with switching threads. And of course, this has repercussions for our requests per second. So 2.9 versus 1.7, which is almost double. That's 1.5-ish, that's 3.0-ish. That's a very, very nice result. We handled almost double the number of requests just by switching on virtual threads. So virtual threads are free scale, and it makes no sense to leave them off. They're a part of Java 21 and later. There is one issue where if you try and do input and output, such as we're doing here when we make network requests within a synchronized block, then that input and output will cause what's called thread pinning. In that case, it degrades down to regular thread behavior. But that itself has also been fixed in Java 24. So Java 24, again, coming out very, very soon, is, I would say, your absolute baseline for building services today. Okay, so we got that. Move back to our service. Good. So we've got our assistant. We've got virtual threads plugged in. I think we're doing pretty good. But how good are we doing? How do we know how good we're doing? Well, observability is the key to good scalable system architecture, right? And we have observability because we have the Spring Boot actuator on the class path here, right? So I have the actuator there, and the actuator gives us a set of managed HTTP endpoints that we can use to enumerate the state of the system. So let's now take a look at what this means for us. Let's go ahead and inspect the observability that we get for free with the actuator. You can do that by going to 8080/actuator, and you get a sort of a menu of different endpoints that are available to you here, including which beans have been configured in the Spring application context, which caches are available, what is the application's health, right? You can see whether the service is up or down or whatever. If it's down for whatever reason, for example, you've got a database that's not connected or something like that, then this will say down, and you'll get a status code 500 instead of status code 200. This will also show you your info endpoint, which is empty at the moment. We'll talk about that in a second. And it'll show you your metrics. And metrics is a very, very good way to sort of understand different things about your system, how long the system has been running, what your database connection pool looks like, whether you've got idle threads, whether you've got too much traffic, or whether you've got pending connections that aren't being satisfied yet, how many requests have been made, how many JDBC connections, what the garbage collection and all that, the JVM situation is, RabbitMQ messages have been acknowledged or not. Spring integration channels. I mean, just all sorts of really important stuff. Tomcat sessions, the load average, all that kind of stuff is here. So if I wanted to see, for example, how many requests that I've got, I can take that to here and then do that. And I can see I've made 5 requests so far. The total time for all 5 of them was this, and the max time was that. And I can also break it down by the exceptions that have happened, and I can see which URLs have been made and all that, right? And this is all powered by Micrometer, right? Micrometer is a vendor-neutral application observability facade that gives you the ability to integrate with all sorts of different sort of telemetry and observability systems like Datadog and CloudWatch and Dynatrace and Elastic and Ganglia and Prometheus and New Relic and so on. You can also do distributed tracing, not just metrics, but what I'm showing you here is just the metric support. So the actuator is very, very convenient. One of the things I love about it is that you can easily plug in arbitrary things in that info endpoint. So for example, if I wanted to info.env enabled as true, if I have that, I can then configure something on the info endpoint. So info.message equals hello Spring fans. Okay, so let's restart that. Okay, go there and you can see we've got a message. But we can go a step further actually. Spring Boot provides some very interesting Maven plugins that can give you even more. One of them that's very interesting is Cyclone DX. So if I go back here and just copy and paste the definition of Cyclone DX, you can see it's already, the version is already managed for us by the Spring Initializer, by Spring Boot. We just have to add it to our build. So I'm going to scroll down here to the build section, the plugin section, add that in, and I'm going to do a quick compile of the code. So Maven package, skip the tests. Okay, so there's the, this is a tool to create a bill of materials. That is to say, it'll give you a manifest that shows you which dependencies your application has and how they're related to each other and what their provenance is and so on. So I can go here, 8080/actuator/SBOM. Okay, you can see we've got an SBOM called application. Click on that, and it shows me all the different libraries I've got in the class path, their hashes, whether they were, where they came from, whether they match what we're expecting, and so on. So this is a jar called Spring Boot Actuator. It's a jar. It's at version 3.43, and it's the publisher is VMware Inc. Spring Boot Starter Actuator, and it's a starter for using Spring Boot's actuator, which provides production-ready features to help you monitor and manage your application. And it gives you all the different sort of hashes that tell you whether you've got the right one, what licenses it has, all this very interesting stuff to understand, how the sausage is made, right? Is it mystery meat or not? Well, this is all here now. Another one that I quite like is the Git Commit ID plugin, and that's also managed for you by the parent ID. So Git Commit ID, commit, there you go. All we gotta do is plug this into our own build accordingly. So go down here, where's our build? Okay, there you are. Reload that, and we'll go back to the compiler. Oh wait, it's not, it only works with Git ID, Git repository. So Git init, Git add, Git commit, -a,-m, YOLO. Okay, and now do the build again. So now I go back to the the info endpoint, and you can see, hey, this is the commit based on this commit. The running code is running this, it's this commit in the Git repository, and it was committed at this time and so on, and it's on the main branch. So you can imagine you do a Git commit, you Git push, goes to your CI environment, pulls down the source code, it then builds the jar and so on. But once it's built the jar, it's going to compute this file and package that in the jar so that when it gets deployed to production, you can now look at the info endpoint and go, oh, okay, the code that's running in production is based on this commit ID that was committed, last night or whatever, So this is very, very convenient as well. So observability is key to having a baseline so that you know whether you've improved or not, to be able to measure and improve. Okay, so we have our service, it's observable, we got virtual threads, we're scalable. I think we're in a good place so far. We've got AI, we've got our HTTP endpoint, we got Spring integration and externalization with Modulith, but I want other kinds of clients to be able to talk to this service as well. So far we've been using HTTP, but I quite like GraphQL. GraphQL is a schema-centric service protocol, right? So I'm going to create a new schema here called adoptions.graphqls, okay? And in GraphQL, you describe the types first. So I might have, let's just do the one endpoint that returns all the dogs, okay? So I'll have an ID, which is an int. It'll have a string name. I'll have a description, okay? There you go. And this is an entity, and it doesn't necessarily correspond to the shape of the objects in our Java code. It doesn't have to at all. You can provide your own representation. And indeed, that's one of the benefits of it, right, of GraphQL. And then when you want to create read-only views of data, you do that with a query. And so we might have an endpoint here that returns a single dog or an array of dogs, a collection of dogs. If you want to mutate the state of the system, you put that definition inside of a special type called mutation. So query is a special type for all the read-only endpoints, and mutation is a special type for the, this is how you would define a thing that takes parameters, for example. You put that into the type called mutation. We're not going to bother with this. It's, it's fine. You'll figure it out. But we're going to do the query, okay? So we'll go back to our controller here. I'm going to say controller class dog adoptions GraphQL controller. Pretty straightforward. And we're going to say, instead of using get mapping or post mapping, we're going to say query mapping, okay? And we're going to return a collection of dogs, and that's going to be called dogs. In order to satisfy that, you can guess what we're going to do. Dog adoption service dot dogs, yeah? Pretty straightforward. And if we go back here, we also, if you look at the config, we have a graphical console that's enabled. So now go back here to 8080 graphical, and there's a nice little inbuilt console that we can use to interact with our GraphQL service. Hit enter, and we get back all this data. Isn't that nice? So we can actually, and if I don't want all that data, maybe I just want the IDs, fine. Remove that from the code, like so. Hit enter again, and now we get just the IDs and the names or whatever. So you can get as much or as little as you want. There's support for all sorts of, aggregation. It's very trivial to do really interesting things there. There's also, through the use of batch mapping, a nice elegant solution to get around the 1+n problem, where you have a bunch of, a cascade of network requests that spawn from loading of one large document that has one-to-one entities, right? This, we could get into that, but that's a whole other video. Point is, GraphQL is very powerful, and you can run it on top of HTTP as we are here, but you can also run it on WebSockets or I think RSocket and so on. It's a very, very nice protocol indeed. Okay, so GraphQL, very, very good. I also want to make it available for people who are consuming our service via gRPC. gRPC is another protocol that we support in Spring, but it's an experimental project as of this recording. And so like I said earlier, I want to make sure that we're using Spring gRPC version 0.50 snapshot, okay? So this is also a protocol schema dependent, schema first thing. So we're going to create a file called adoptions.proto. And then in there, same thing. We're going to create a service called adoptions. And, the syntax will be proto3. And it's going to have an endpoint of type RPC that's called all. And it's going to return dog's response. And it's going to take an empty, it's going to take void basically, right? So we need to import the type that is used to express voidness, okay? So google.protobuf.empty, okay? And what is this dog's response? Well, I need a thing that'll hold a repeated set of dogs, which is another message type. So I'll say repeated dogs. And then in gRPC, it's based on Google Protocol Buffs, and Protocol Buffs works so splendidly because it makes you describe the shape of a message that can be sent over the wire via the protocol and to declare its offset in the message. And so therefore, you can keep backwards compatibility if you change the message, as long as you don't rename or change the first whatever number of fields in the message, right? So as long as this is always at position 1 and so on, then that'll always be backwards compatible. So for example, I can have int32 id is 1, string name equals 2, description is equal to 3, right? And notice that it's a compiler error. It's an error if I say 2 because it's already been used. It has to be unique. So this is always backwards compatible. I can send a new version of dog to this old service, and it'll still know how to read the first 3 messages. If you add new fields, it won't know what to do with that data, but at least it'll know that the first 3 fields are what it's expecting, right? And that's very, very powerful. It gives you longevity when you build your services, right, to endure. Okay, so that's a basic definition. But remember, this is a code generation technology. You have to transpile your schema into a client, and there's a Protalk compiler. So to use this, you're going to need Protalk on the command line, okay? I've already got it installed, and in order to support that process, I'm going to provide a few options here, telling it how to compile my schema into a Java client. So it'll be option outer class, and it'll say adoptions proto, and then we'll say option package, okay? com.example.service.adoptions.grpc. I just call it gRPC, fine, okay? So that's basically a full-blown thing there. Let's go ahead and compile this code into, to get the compiler to create the source code for us. And thankfully, the Spring Initializer is already done, it's already configured the Maven plugin for Google Protocol Buff. So now, if I go to my target directory, in the generated sources folder, I've got these two folders here. And I need to make sure these are sources in my ID, my IDE, right? IntelliJ will not automatically do that for you. As I understand it though, Visual Studio Code and Eclipse will, so you are in luck if you're using that. Okay, so I'm going to add that, and now I need to implement, or extend rather, the generated code that they gave us. So dog adoptions gRP service extends adoptions gRPC imp base, okay? And you can see it's given us a base version of the method called all. I'm going to override that and implement it by delegating, as always, to my dog adoption service. Okay, that. Now we're going to say var all equals dog adoption service dot dogs dot stream, and I need to map each OG dog into the code generated dog that's on the transpiled code in my gRPC package. So I'll create a new builder and then build it, and then we're going to turn that into a list. Okay, now for each one of these dogs, we need to copy the field. So ogdog.id, fine. Set name to name, fine. And then those will be description, set description, etc. Now, remember, mind you, if you have nullable fields, that's going to be a little bit more complicated. You have to make sure you clear it. You can't just pass a null into the field. I don't know why, but it gets more tedious. It's not a one-to-one like set like that. So, okay, I've got that. Now I'm going to create the reply message, which is a dog's response, new builder, add all dogs, all, and then build it, right? I'm going to return response observer dot on next. That's the reply, and I'm going to tell the client I'm done processing, and it can close the socket now. Okay, there's my implementation. Let's restart the code here and try it out. And if we go to the command line, we can use the handy dandy gRPC curl. This is an extra command line. It's not curl, but it makes it very trivial to interact with gRPC services. Spring gRPC detected that we're running inside of Tomcat, and so it stood up our gRPC endpoint inside of Tomcat itself. So here we go, plain text, localhost 8080, and we're going to call the adoption service dot all. And there we go. There's our gRPC data coming back from the service in the output there. Isn't that nice? Very good. So now we have gRPC, GraphQL, and HTTP all doing basically what we expected to do, and it was trivial to do so thanks to Spring's endless integrations. Okay, so now I think it's time to turn our gaze towards production. We have a service, but it's not secure yet. We've got the observability, we've got virtual threads, but this isn't yet secure. So what we're going to do is we're going to go and lock it down by requiring that all requests to this service have a OAuth access token, and they can only get that access token by talking to an authorization server in the likes of Okta or Keycloak or Active Directory or whatever. There's a million different authorization servers out there. We have one called the Spring Authorization Server, which I love because it's delivered as a Spring Boot starter. It's just a set of auto configurations that give you a full working OAuth 2 OIDC compliant authorization server, and it works in the same way as everything else we've done so far. Just override the auto configuration as necessary. So let's go back here and we'll stand up a new service called Auth. We're going to use the Auth server support. We're going to use the config client support and the web support. And we're going to hit generate. Open this up in our IDEs. So just as before, point it to the config server. Okay. And we're going to now specify how this is supposed to work. Okay. We have a few things we need to worry about here. First of all, we also need to add, well, first we need to add the users, right? So the way OAuth works is You go to a protected endpoint, it detects that you don't have a token, it redirects you to an authorization server where you are then prompted to log in. And once you've successfully logged in, you can be asked, or you just implicitly are permitting the server to then give the client that initiated the request for the token in the first place permission to act on your behalf. So it forwards or redirects back to that client with a token in tow. So you've probably done this before. You've probably clicked on log in with Facebook, or log in with my Gmail, or log in with my Apple ID, or something like that, right? What that does is it triggers a flow that redirects to a trusted provider, the authorization server of your choice, in this case Facebook or Google or Apple or whatever. They ask you if you are okay with whatever having your information, and if you say yes, sometimes I'll even stipulate down to the more granular level, like I want them to have my ability to read my calendar, to modify my email or whatever. And then if you say yes, you consent, it redirects back to the thing that initiated the flow, giving them the token that allows them to now drive network requests, REST calls to Google's API or Facebook's API or whatever on your behalf with a token that you allowed them to have. So this is what we need to do here, is we need to describe two things: how the auth server, what capabilities it's going to have, and then we need to describe one of these clients that the auth server will know to work with, okay? And you've probably set up if you've gone to developer.twitter.com or developer.facebook.com or whatever, then that'll be, that's a similar thing where you're registering apps that interact with those providers. Okay, so let's go here. We're going to set up a Spring Security filter chain, okay? This is your, go-to thing for all network web service-based applications. We're going to set up form-based login. We want people to do a login via forums. We want to restrict any request going to the auth server and require a token, require permission. So none of this is auth server specific. You could do this in any Spring app, right? And you could do it, again, we could do this back in the service that we just created, but I don't want to do it in every single microservice I create. I'd much rather set up these rules and lock down every service and just have all requests go through the auth server, right? So I'm locking down just the auth server. I'm telling it I'm allowing form login. Form login is just one of many options. You also have one-time token, which is super convenient, right? You should customize this, right? There's a token generation success handler that you should call. This is really cool. You've probably had this before, where you click on login, you enter your email, your username or whatever, and then they send you an email, and you click on the link and now you're logged in, or you get an SMS or something. That's what that gives you, is the ability to send an out-of-band message, which goes to what would be considered one of your other factors, and they use that to ascertain that you are who you say you are, because only you would have access to that SMS or to that email or whatever. Okay, form login, we can do that. Another option that is really convenient is WebAuthn. This is also very nice. This uses passkeys. Passkeys are, you've probably used this before, where you go to an app or something, or a website, and you can now use your thumbprint, right? Like I'm on an Apple ecosystem device. I can go to some websites, and if they have checkout with my Apple Wallet, I can actually use my thumbprint or my fingerprint to pay for something on a web page, right? Same thing for Face ID, right? I can do all sorts of things from web pages now using these extra factors, like my biometrics on my device, my laptop, my phone, whatever, or even my watch. Sometimes I get prompted to click to confirm the purchase on my watch, but this isn't unique to Apple. You can use all sorts of different technologies and get the same result. Okay, so there's the form login. We're going to just stick with that to keep it simple for now. We want to also configure the authorization server. We need to actually add that, don't we? So we're going to use this extension hook called with. Here we go. Bring that in, and it's going to ask us to configure some stuff. We really only need to configure the OIDC stuff, and even there, I'm just going to defer to the defaults. So this is the only thing that has to do with the authorization server, and this stuff we're not even doing. So really, if you think about it, it's like 4 lines of actual code. We also need to configure users. I'm just going to hard code some users here, right? This is not what you would normally do. Normally you'd have a database, or you'd have Active Directory or LDAP or something where you have users. But I'm just gonna, actually here, var users equals set.of, and we'll say user.with username. My username is JLong. My password, well, my password is PW. Don't tell anybody that. But I'm going to encode it. It'll be stored in memory encoded, right? And what I mean by that is behind the scenes, Spring Security when somebody logs in, they're going to take the thing that was passed in, encode it, and try and match to confirm that the encoded representation of your password that lives in memory in this user matches the encoded representation of the message that is sent from the client, okay? And so finally, what else do I need to specify? A role or many roles. I could be a role, admin, user. These are arbitrary strings. Whatever makes sense to you, you can specify them here. I'm just going to say I'm a user. You could have more than one user as well, right? I mean, there's nothing stopping you from doing that as well. So, I'm just doing one user just because that's the only one I want to make work right now. And I think we also need a password encoder, okay? So by default, Spring Security has a bunch of different password encoders, and it's got a nice scheme based on this composite password encoder where it'll encode the encoder in the password itself. So you might have like bcrypt, you might see a string in your database or in your password in your user details service. You might see that it's got a string called that is prefixed with curly bracket bcrypt and then a bunch of random, encoded. This is the hashed representation of the password, right? Well, if it's bcrypt today, that's great, but maybe 5 years ago or 10 years ago it was SHA-3 or whatever, right? Or SHA, whatever. So now I can, if I see just a random string of numbers, how is Spring Security to know which encoder to use to try and match it, right? So that's what this does, is it gives us a way to look up the current encoder. And if you look at this, it's got a map of different encoders that get encoded in the password itself. Okay, very, very convenient. So this will be, I think, by default for today in March of 2025. It'll be a bcrypt, but who knows? There might be like a post-quantum password encoder or something like that, right? All sorts of interesting things that could have come about. So this is now a auth server. I think that's it. Let's go ahead and start this one up. I think that's it. Let's go ahead and start this up. One thing I just realized, maybe it's better to prefix this with my, to avoid any possible duplicate names. I don't want beans with their names colliding. So do something like that. They'll still get matched by type, but I don't want them to conflict with something provided by the framework itself. Let's go ahead and start it up and see what that does. Okay, that seems to have worked. Remember, this is going to work in tandem with the configuration in our config server. And so you can see over here, I've got this config. What is this? Get rid of that. We've got this file here called auth.yaml, right? You can put property files or YAML files in the Spring Cloud config server. And here we've got a bunch of different clients, or well, we've just got one actually. We've got one client, one application that is allowed to interact with the auth server. So when the client eventually redirects to the auth server saying, hey, I want to authenticate this user, it's going to say, I am an instance of the client called Spring, whose client secret is Spring, which is no op. It's not encoded, right? It's not bcrypt or anything. And when you're done authenticating the user, if there's a token to be had or not, return back to the client running on port 8081. We haven't set that up yet. We will, right? The other thing to keep in mind is this auth server will run on port 9090, okay? This is YAML configuration. You could also have a Java object, programmatic. There's an interface here. You can actually write your own implementation that writes to a SQL database or whatever, all these different clients, and you can have your own self-service sign-up form so that developers can sign up and register their own OAuth clients and so on. So that's up and running. Now let's go back to our service and tell it to reject requests that don't have a token that originates from that auth server. And the way we do that is uncommenting the resource server definition that I had earlier. So this will reject requests that are unauthenticated, but it won't originate the token in the first place. You still have to get the token from somewhere, and that will be the business of the client that we're going to set up in here in a second. Okay, that resource server config will validate the token, and it validates the token by talking to the auth server on port 9090. Here's that property for service.properties, spring.security auth2 resource server issuer URI equals blah, right? Okay, so we now need to build a client, okay? Refresh, client. And here, we're gonna use Spring Cloud Gateway, okay? We're gonna use the web support, the config client support, and the OAuth client support. So we want to be a client. This is like a resource server, but it has one extra step, which is it'll reject requests, and if there is no token, it'll redirect the user to the auth server to do the authentication. We call that the OAuth dance, okay? So this is like resource server plus plus, okay? But otherwise, it's basically the same. Go ahead and load that up, UAO client.zip. Okay, now in the config, just like before, config server, and we're going to go to the code here, and we're going to define a Spring Cloud Gateway, micro proxy. Spring Cloud Gateway is a proxy that you can use to transform requests, to add filters to the processing and so on before they go downstream. And we're going to use here a very convenient mechanism, which is that Spring Cloud proxy, a Spring Cloud Gateway. This is what it looks like normally. This is not actually Spring Cloud Gateway's DSL. This is the functional HTTP controller style in Spring Framework, right? And you can use this or the add controller style. And if you wanted to do a basic HTTP response, you do that, right? So you can imagine I have a request that goes to /** on port 8081, which is where this client will be running. And then I simply make a request to the downstream service, right? I could even use the REST client, right? RC equals REST client dot builder dot build. I could make my own request and then get the response and then send that back in the response to this request. I could do that, right? But Spring Cloud Gateway has I can get the full power of Spring Cloud Gateway and bootstrap, on top of this component model here. So I'm going to use this syntax instead. This is a static method from Spring Cloud Gateway. I'm going to say when a request comes into localhost 8080 / then send everything after the / to localhost 8080 so it's going to come to 8081, it'll get proxied over to 8080. Okay, and I only want to proxy it if and only if there is a OAuth token in request in the body. Okay, so I'm going to add that filter, and this comes from Spring Cloud Gateway as well. Okay, now I think I'm pretty good. Let's go ahead and restart this. I remind you, this is going to be getting its configuration from the config server. So we're going to go to the client, and you can see we have the mirror image of what we had on the auth server. We have the resource server. We have that we're pointing it to the issuer URI, but we're also telling it to act as the client Spring with the client ID Spring and the client secret Spring, and here's the same sort of thing, telling it where to redirect back to once it's done. So this is the client perspective of the registered app that we registered in the auth server. Okay, so that's up and running, and that's on port 8081. Let's try it out. 127.0.0.1 8081, and we're going to go to dogs. It says JLong PW, that's my username and password, redirect, and it takes me to dogs. Great. Now, how do I know if it's worked? Well, what if I go back to my service and I create a little HTTP endpoint to show what the current logged in user is, okay? So maybe I just do that in the actual root type here. At controller, at response body, class, me controller, okay? And I'll say get mapping, me, string me. And I'll just inject the current authenticated user like so, using Java Security API, get name, okay? So that'll be that'll get restarted automatically, and I can just go here and I can see my current user now. So the service knows that I, JLong, am accessing it, but the service is running on port 8080. I'm making the request from 8081, and it's proxied it transparently, and it sent the token along on our behalf. And remember, this is a proxy, so I'm proxying all the API calls downstream from the client. Where's that client? It's over here somewhere. I'm proxying all the requests downstream from, assuming /**, but I could also do something like /API /**, and then have another get endpoint. I could have another router function, in fact, that proxied my JavaScript, right? And so people would go to 8081 and they get the JavaScript at / and they get /API and get the API. And so you could serve the JavaScript and have it call itself in the same domain, therefore sidestepping cores and all this other tedium and getting a very, very nice experience. Okay, so now we've built an end-to-end system, secured, we've got everything in there. I think we're ready to take this to production. And a couple things we should keep in mind here is we want to be able to get a performant version of our application. Our code's using Java, and obviously Java is very efficient, right? There's this wonderful blog, which is a review of a study produced by some Portuguese back in 2018 that asked the question, which programming languages use the least electricity? And of course, our friend Java is in the top 5 most energy efficient languages. C, of course, is the most energy efficient. Rust, doing quite well. Zero cost abstractions, well done. C++, tooey, disgusting. And then Ada, nice. And then Java, Okay, so twice as inefficient or not efficient as C, but still top 5. And remember, Java is a virtual machine, right? So it's very energy efficient. It's also very performant. You might have seen the 1BRC challenge from my friend Gunnar Morling about a year ago. He asked people to submit a program to load 1 billion rows of weather station telemetry data, or about 13 gigabytes. Some people are very surprised by just how fast Java is. So I've asked people at numerous conventions and conferences and talks and whatever, and some people give me like half an hour. You know, how long does it take to load 13 gigs of weather station telemetry data? Half an hour, 5 minutes, 10 minutes? Well, you'd be surprised to know it's actually much less. It's about 1.5 seconds. Where's that result? Here we go. 1.5 seconds, right? 1.58 seconds is the number 2 entry, 1.6, 1.8, 1.9, 2.0. So just incredibly fast. And the number 1 entry, in fact, in most of the top 10 entries are all using GraalVM native image technology. And this GraalVM native image technology is an OpenJDK distribution. Here's OpenJDK. It's like it bundles OpenJDK, but it provides extra features, and it's released by Oracle. It's the same. Both Oracle staff released both OpenJDK on the day of the release, and then a few hours later, somebody else, a different team, releases GraalVM, which bundles OpenJDK plus some extra utilities. And one of those utilities is a native image compiler. That native image compiler turns your code into operating system and architecture specific native binaries. So let's go here, and I'm going to do skip tests p native compile. Okay, and I'm going to let that run in the background. That's going to take my code and turn it into an operating system and architecture specific native binary. Obviously, this does take a lot longer than you would hope, and the reason it's taken so long is because it's going to scan your code starting from public static void main, and it's going to cascade out, going to every single part of the code base and finding unused code. Anything that isn't used, it's going to throw it away. And it does this unfortunately on every single compile. But the result is that it's like dead tree shaking for JavaScript. It's going to get rid of all the dead code that isn't being used, that's just inert on the class path. This is amazing in terms of your startup time and the RAM footprint. It's also great for a security perspective, because the last thing you want is types that you're not using, but that are somehow potentially vulnerable to reflection. That's exactly the log4j, log4shell vulnerability a few years back. That's exactly what that was, right? So this sidesteps that. First of all, you can't do reflection without configuring explicit permission for that. And second of all, you don't have those types probably in the first place, the dangerous ones. Okay, so it compiled, took about a minute. Let's go to the target directory and run it. Here we go. Oh, the port's already in use. Let's go back over here. Look at that, everything turned off, turned to night mode. So stop the service, and here we go. There we go, 0.34 seconds compared to a full second. And remember, that's got everything. It's got the kitchen sink and so much more. And more importantly, here's the process identifier, PS-O. I'm going to measure the RAM, and this number is in kilobytes, so I divide by 1,000. So a fully loaded web server, AI, messaging, integration, data access, security, gRPC, GraphQL, a console, and just everything, everything, observability, all that stuff. And it's about 198 megs of RAM compared to what I'm sure is easily 500 or maybe a gigabyte for your JRE-based applications. Yeah, I mean, remember, just the JVM by itself takes hundreds of megabytes of RAM. So this is a really, really good result. This gives you the ability to build operating system and architecture specific native binaries that are just blazing fast. We're using this for a service, and it's going to be I'm on a Mac, so it compiled a Mac binary. You don't want to use that obviously in production, so you would typically run this in your CI environment. You can even use Spring Boot's support for building Docker images. So you could go here and do something like maven d skip tests -p native, and then do Spring Boot :build -image, and that'll end up building a Docker image which has a Linux binary inside of it that is a native binary. And you can then just Docker tag and Docker push that container to your registry of choice. So there we go. We've done it. This has been a abbreviated look at the wide and wonderful world of Spring. I sure hope you got something out of it. So there you go. We've done it. This has been an abbreviated look at the wide and wonderful world of Spring. I sure hope you got something out of it. We've tried to just look at some of the things you might need when building modern software in 2025. Obviously, there's some other things that we didn't get to look at, like Spring Shell. One of my favorite projects is a great way to build shell-based applications, CLIs and shells, REPLs, things with tabs and new line and read line support and, all that kind of stuff on the CLI. And that pairs, of course, very nicely with the GraalVM native image support that we just looked at here. We didn't look at the Spring State Machine, which is a great way to sort of describe not workflows, but state machine progressions and so on. And obviously there's a million other tricks you can do with each of the technologies that we looked at here. So, we've only really just begun to scratch the surface of what's possible, but hopefully you have some ideas here and you feel inspired to take it further and get on your journey to production. My friends, there's never been a better time to be a Java and Spring developer. And of course now, now I've adopted another dog. So that's a good time. It's a good life. Thanks for watching. See you next time.